Hello guys, welcome back. We are working on our UEFI bootloader in Zig. Last time we worked on this example, EFI application, and today we are going to start doing actual work for our bootloader. And the same way we did for our second stage bootloader, the first thing we are going to work on is some sort of system that would give us the ability to have logs, debug logs, or something like that. And that would make our lives easier when we are trying to do more complex stuff. So that's what we are going to work on today. So for our second stage bootloader, that took the form of a printf function that basically printed things to screen. And this time I thought I would showcase another way to basically output debug logs from operating systems or in general embedded systems, and that is by using the serial ports to output the strings, the log strings. So that's what we are going to work on today. Let's get started. All right, so the first thing I will do is probably get rid of these two things here. We don't need those. Let's keep for now this thing here that prints the keys, just in case we want to see if our application does something. And let's get started by creating a new file here. I'll call serial.zig. Yeah. So I guess before we do this, we are going to need to define a few things. Well, first of all, let's import std. So import stud, and with this we should be fine. So let's define a few enums. I guess that's how you do it. Let's call this one port, and this would be an enum with a back in U16, and we have 8 ports generally. I don't have the values in mind, but I'll grab them in a bit. For the values, we can find them online. There we go. So let's also define a sort of enum that would give us the port offsets and what they mean. So let's call it offset, I guess. And this would be just a U8 because we only have 7 of those. Or should I say 8 of those? Starts with 0. So the first one would be the receive and transmit buffer, and this would be a 0. Then we have the interrupt enable offset. Then we have the first in first out control buffer at 2. We have the line control at 3. Then we have the modem control at 4. Then the line status is 5. And then the modem status at 6. And finally, we have a sort of scratch register at 7. We're not gonna use that, but yeah, at least we have something that's complete. Right. Okay, so we have these two, and we want to start working now on our serial writer, I guess. And I think we are going to do this the SIG way. So let's create something that's called serial writer. And this would be a struct. And what I mean by the SIG way is that we are going to have a function called init that would basically take a comp time port of type port, and it would construct a serial writer for us. I think this is okay. So I guess one thing we need is to define, so const self is equal to add this, just to avoid having to type that. And I think we are also going to save the port. So let's do something like this, type port. So the idea is basically to create one serial writer per port and just have that created for the lifetime of the application. Right, so let's do this. And we want this to be to obey the writer interface, the Zig writer interface so this would be the interface at std.io any writer, I think. So we need to obey this interface here, have this sort of things, or actually there's another thing that we can obey, which is called generic writer. Oops. So this one here can construct a writer from a context type, an error type, and a write function that has this form here. So that's what we are going to do. So let's create a so pub const, call this writer, and this would be std.io generic writer that takes a context which would be just ourselves, I guess. So const self, since we have no state to change, we're just going to take a const pointer to ourselves. Then we have the error enum, so I'll just call that serial error. And then we need a function that does basically the writing to serial, and I'll just call it write for now. And of course we need to create those two things. So pub const serial error, and this would be just for now just an empty error set. Oops, that's there we go. And we of course need the write function, so I'll just make a sort of quick mockup here. It takes a self, which is hold on, let me just check what it takes. So it takes a context and a bytes array of U8. Right, so let's change this. This would be context, and this would be just a const pointer to self. And then it takes bytes, which is an array of const U8. And it returns serial error or usize, if I believe. Usize, I believe, yep. Usize. There we go. So that's our function for now. Yeah, so it's complaining that the variables are not used, but that's fine. Right, so let's, I guess the return type from this would be, so port is equal to port. So we just create a new instance of serial writer by setting the port to this comp time port that we get passed here. And before we return, we need to do serial port init. So there's a sort of there are a few steps that we need to go through to initialize the serial port. And I guess the write function will also need to be, we can actually write the write function. So I guess we can const port is equal, I guess we can call this self. We know it's so self.port, and of course we need the so this port here is of type port, which is an enum. We need to convert to the corresponding ID, or should I say U16, the port number. So let's do that by calling port number is equal to, so int from enum, I believe, and we pass it port, and that should be fine. Okay, so it's complain that it's not used, and then here we need some function that would write a string to a port. So let's just assume that we have a function called outString that basically writes, takes bytes and the port number actually. There we go. And of course here we need to return the result of this. Right, so let's try to see what this initialization sequence is like. And so I guess before we do that, we are going to need two methods to actually write to a CPU port and read from it. And basically it's this will be very simple methods that just use the out and in instructions, assembly instructions. So that's what we are going to do. I'm just going to create a new file here and call it io.zig. And in this io.zig, I'm going to create a public function which I'll call outByte. And this will take basically a U16, a port which is U16, and it will take a, I guess, value, which is a U8, and this is going to return void. Yeah, this is not Rust. Right, and the way we are going to do this is we are going to return, we are going to use Zig's inline assembly syntax. So we want this to be volatile. And this syntax is, it looks like the LVM and JCC inline assembly syntax in C, but it's a bit different from those. So let's see. We are going to use outB, and we are going to pass it a first argument, which would be the, I always forget the way they go, but I think this one would be the port, and this one would be the value, I think. Right, and then we have no return, so that one stays empty. And we have inputs. So the first input would be called port, and that one is of type. So we just put it into, so the X, the port goes into the X. Basically this is, so basically this is where I'm taking the syntax out of. So the out instruction takes the port and a value. The port is in the X and the value is in AL, and it basically outputs the value onto the port. So yeah, the port goes into the X and it binds to the variable port. So basically here is, so let's go over the syntax with, I guess, an example here. So let's assume that we have some return type here, and here we'll have some something like this, and here we'll have this syntax here. Or we can also have this syntax here, which is... So basically what this means is that here we can have, so basically 2 backslashes are multi-line strings in Zig. And these are basically our instructions. And we can use these percent brackets and variable name. But these variable names are actually not these ones that are defined in our as our arguments. These are the variable names that we can define for our instructions here. So what's between brackets are the variable names, and the string next to that is the type of the variable name and how we interact with it. And then in the parentheses here, we have the binding. So after the first column here, we have the return types. For now, I think Zig only allows one return, but I think there are plans to allow for multiple ones, but I'm not sure about that. But for now, just one is enough. So here with this syntax here, we are saying that the return of this ASM block would be this value here, ret, if we had a return value, of course. And of course, here we could also have some specific register. We can say something like, so RAX. And basically, whatever goes into RAX after our instructions execute gets returned here by this ASM block. So after the second column are our input variables. And for example, here we have a variable called port, which is this one here. And then we bind it to this parameter that we get here, which is the port. So basically, we say that this variable port here would be in register dx, and the value that it gets when this function is called is whatever is in this other variable. And of course, they could have different names. So this one could be port 2, and this could be port 2, and this still would work. And I guess we should do pretty much the same thing for, what's it called? Value, I called it. So value, and this one here would go in AL, I said, I think. Yep. And this one would get bound to value. Right. And of course, if we have any registers that get clobbered by this call, we can specify them after this third column here. We can specify, I don't know, RSI, for example. So this is basically the inline assembly syntax in Zig. So for our purpose, we don't really have this, and we don't really have this either for this out B instruction here. So I think this is what we are going to have. I'm just going to rename this back. And I have a doubt about the order of the variables. I think since this is AT&T syntax, I think value should go here and port would go here. Yeah, we'll check this in when we build this. So let's also create a pub function in B, which was basically do the same thing. So it take a U16 port, and it would output a U8. Right, and this would be pretty much the same thing. So volatile, and let's do this. And here, of course, it'll be in B, and it will have the port, and then it will have the I guess value. Let's call it value again. And this time we have a return, which is our value. And this value here will be stored in AL. So we are going to specify that we want this to be taken from AL. And of course, we want to just return it as the return of our function here. So it's a U8. And here we have one input value, which is the port. And that value, of course, is bound to, or actually it's put into the X again. And it's bound to port. And we have no global registers for this either, so that looks okay. Again, I'm not sure about the order of the operands here. Might want. I know that it's the opposite for out and in, but I'm not really sure. I don't use AT&T syntax that much. I don't think anyone does though. Right, so let's go back here. Let's go to the top here and just import IO, which would be import, what did we call it? IO.seg. There we go. Oh, right. And now what we need to do is just do a small thing here. So first of all, let's get the port number, because we are going to do that, need that. And that would be int from enum of port. And then we are going to do out b. We are going to write to port number plus, so int from enum. So first of all, we are going to take the, so we are going to disable interrupts. What we call that? Offset.interrupt enable, and we'll write a 0 to that to disable interrupts. Then we are going to io.outb, same thing, so port number plus int from enum offset. So next we are going to write to line control, and of course we are going to need to know what line control structure is. So for that we have here the structure of the line control register. So we are just going to go ahead and define this in Zig. Right, so the line control register, so let's just define it here. So this would be const. Yeah, I'm not gonna make these public. Let's make them just private to our module here. So line control register, right? Let's create this to be a struct, and in Zig we have this thing called int backed structs. So basically it's a struct that gets represented by an integer, and that's what we are going to use. So basically the struct will have to be the same as the same size as the integer, and it's very interesting to represent bit fields, which is basically what our line control register is. Right, so the first thing are two data bits. So these, we have two of those bits, so it's a U2. And we are going to set default values for every field here. We have one stop bit, so that's a U1. And we have parity, which is a U3. We have 3 parity bits. I'll set that to 0 also. And then we have a break enable bit. So it's just one bit, it's a U1. And then we have a so a divisor latch bit. So it's the short term is dlab, and that's just 1 bit. There we go. So basically, when this dlab bit is set, these two offsets here are used to set the baud rate divisor for this serial port or serial channel. So const, let's also do the other one that we are going to need, which is the FIFO control register. And this one here is a struct of U8 backing also. And if we take a look at its fields, you can see that we have enable, which is just 1 bit, clear 1 bit, clear transmit, clear receive, which are 1 bit each, DMA mode select 1 bit, and we have 2 bits here that are reserved and 2 bits which are the interrupt trigger level. So enable, this would be just a bool, so just a true or false. Of course, we'll set to false by default. Clear, so clear receive, call it clear RX. I'll also set it as a bool, and clear TX transmit bool, and so we have a reserved bits, I think 2 of those, and that will be just set to 0. Actually, I'll set them to undefined since we're never going to use them. And int trigger, interrupt trigger, which is 2 bits, so U2, and I'll set it to 0 by default. Okay, so let's go back here. We were trying to write this, and here we want to set the dlab. So we are going to create a control register, and we are going to we are just going to set dlab to be 1, and I think we need to also convert this back to an U8 because we want to pass a U8 to our outb function. We're just going to call bitcast on that. I should do that nicely. Right, so now that we have set our dlab, we are going to set the divisors for the baud rate, and to do that we are going to set so offset 0, so the one that we called RxTX buffer. Actually, we need to convert that to int. So int from enum of that, and we are going to set that as 3. So basically, this thing here, this says if dlab set, this would be the divisor's LSB, least significant byte, and this one here, if dlab set, it's the divisor's MSB. There we go. So does this mean that we have missed something? Oh yeah, of course. These need to be backed, otherwise it's not going to work. So these need to be backed. That's pretty good. Right, so here we are going to set outb port number plus int from enum of offset, and the second one is int enable, and this I'm just going to set to 0 because we just want to divide by the max baud rate divided by 3 is our goal here. Right, so now that we have done that, we are going to just go ahead and unset the dlab. So int from enum, so that offset line control, and and in that we are going to bitcast a line control register with actually let's unset it and set the data, and we want this data to be 8 bytes. And so if I go back here, we can see that so data bits is basically the number of bits that the characters are encoded on. If the 2 bits are 0, we have 5. A value of 1 is 6, a value of 2 is 7, and a value of 3 is 8. So we want 8 bits per character, so we are going to set data to 8. So stop bits we have, if bit 2 is set to 0, we have 1 stop bit, otherwise we have 2, not 1.5. 1.5 is only for 5 characters, and 2 for the other ones. So we want 1 stop bit, so we'll set this to 0. Parity bits we want none, actually. And that's pretty much it. So that's what we are going to set. Right, so here, by doing this, we are basically telling Zig to initialize the other fields with these default values that we have given them. So basically we are going to set data to 3 to get 8 bits per character, and the other ones will be set up nicely for us. So now that we have done that, we need to basically set the enable the FIFO register. So let's do this plus int from enum, and this would be offset FIFO control. And in this, we are going to bitcast so FIFO control register, and we are going to set enable to true. We are going to clear Rx, and we are going to clear TX also. Just going to set it up nicely. Let me get rid of this. Nice. Okay, so now that we have that set up, we are going to take a look at the modem register. And to do that, let's look at what it looks like. So basically we have just a few bits here that we need to create a struct for those. So let's do that. So const modem control register is a struct, actually a backed struct of U8 backing, and so what were the fields? So DTR, RTS, out1, out2, and loop, and 3 unused bits. So DTR, which is AU1, RTS, ready to send, which is AU1, or request to serve to send, and so out1, I believe just 1 bit, and out2, which is just 1 bit also, and the loop, which is a boolean, and can set that to false. And then we have reserved as a U3. Just set that to undefined. There we go. Right, so now that we have this, we are going to do out B, and we are going to take port number and add to that int from enum, and that would be so offset modem control, and we are going to write to that bitcast of modem control register, and we are going to set I think we just need to set all of those to 1. So DTR would be U1 and RTS be 1 and out1 will activate out1. Oops. Yeah, so activate out1 and activate out2. And then we are also going to set loop to true, and that would be for the purpose of testing our serial connection. So we are going to write something to it, and we are going to read something back from it. And if those are the same values, then we have actually set up our connection or our channel. Otherwise, we have some issue somewhere. Right, so now we are going to try to actually send something on our channel. So let's write something to our RX register, so int, TX register, so int offset dot RX TX buffer. And to this buffer, I'm just gonna write AA, for example. There we go. So we are going to read from it. So io.inb, and we are going to read from port num, and that should be, so if this is not equal to the value that we've written, then we have an error here. So we need to do something. So for now, I'm just gonna mark this. Yeah, I don't want to handle errors just yet, so I'm just gonna mark this as unreachable, and we'll see what we get. So if everything is working correctly, we are just going to disable the loop on our modem control register, and we'll be good to go. So out B, so port number plus, so int from enum of offset modem control status, or rather modem control. And here we are going to again do a bitcast of modem control, modem control register by saying the, actually, maybe I should just go ahead and set these to 1. That would make my life quite a bit easier. By default, I mean. Yeah, so I can just do this. And here I can just do, actually, I can just do this. Oops, there we go. So with this, we should have initialized our serial port for this port that was chosen here. And we should be able to now use this write function to send things out this port. We still need to write this outstring function because now we have an array of bytes, and we want to send them all out. And we can do this one of two ways. We can either write a for loop that basically goes through all the bytes and sends them out using our out B, or we can be a bit smarter than that and use the out SB or outstring byte instruction that basically takes a pointer to a string and a size and basically does that for us. So let's do that. So we'll take a port, which would be a U16, of course, and we'll take bytes, which would be a slice of const U8, and this would return a U size because we need that for our writer. Right, so we are going to again. This time we're not going to return the assembly. So let's first volatile write our assembly code here and see what we need to do. Right, so let's do, so this would be rep out string byte, and out string byte would basically take no argument, I think. Yeah, it does not take any arguments. And then we are going to take a return value from RCX, and I'll oops, so RCX, and this would be basically outed as a usize, output as a usize, and then we are going to take so the port would be set to dx again. So the port would be set to dx, I believe. And the port, of course, is bound to port. And then we have the source, or yeah, let's call it source. And this would be set to RSI. So RSI, of course, this is a register. So let's do this. And this is bound to bytes.pointer. And of course, we need a length. So length would be put into RCX. And this length here would be bound to this dot length, bytes.length. And of course, this time we have registers that get clobbered, which are RCX and RSI. And what this would do is basically rep takes a counter value in RCX and decrements that and repeats this instruction until RCX goes to 0. This instruction here expects a port in DX and a string in RSI. So it basically takes the string in RSI and outputs it in the DX. And of course, we have set the length in RSI, and we are taking that back as an output. And it basically is the number of bytes that we haven't written, we couldn't write. So const unwritten bytes, for example. And here we are going to return, so bytes.length, that we need to return the total bytes that we have written. So we need to just basically take the total bytes minus the ones that we couldn't write, and that would give us the number of bytes that we wrote. And I think that's about it. Yeah, it looks okay. I guess I've seen something weird here, so I need to put this like so, and otherwise we are looking okay. So this this here would be now an io.outstring, and that should be our serial class done, I believe. Yeah, looks pretty good. So let's give it a try, I guess. So const, let's first maybe import it. Const serial would be import, and we called it serial.zeg. There we go. And let's not forget that. So serial is equal to serial. Okay, so maybe it's not a good idea to do it like that. So let's do serial dot serial writer dot does this? Okay, no, so it's init, and the init takes a port. Right, that's how we do it. We did it. So serial, okay, then maybe we could actually do this and go over here and call this serial writer. There we go. And this would be serial writer dot. Wait, I think we forgot to make the ports public. No, we haven't. Oh, okay, I see it. So this one is just port. There we go. Yep. So let's take com1, and this one here is, of course, just serial. It's whining because it's an unused value, so let's use it. Oh, right. We still haven't finished this, I think. Yeah, we still haven't made this 100% equivalent to the, or obey the writer interface. We need to have another thing here, another public function called writer, which will return a writer of type, this writer type that we've created here. And this would basically just return a writer thingy with context set to, I guess, self. And this would need to take a, this need to take a self, which would be a pointer or a const pointer to self. I believe that looks pretty okay. So if we go now here and do dot writer, yeah, we should now get a generic writer. And if we do serial writer dot, and now we should have these methods that are on the writer interface. So we can do write, for example, and we can do hello serial. And of course with this, and we now have to, so does this return anything? Of course it returns an error and a U size. So let's just mute the error by doing catch unreachable. And let's just mute the value, the U size, by doing this sync here. Okay, so let's build this and see what we have. Okay, so we have an error here. Back in type U8 has size 8, but the structure has size 7. Okay, maybe we've forgotten something, and I think it was for FIFO. Yeah. So what did we forget here? Oh yeah, we forgot this DMA mode bit. So let's put it here. So DMA mode, and this would be a U1, and it defaults to 0. I think that should be okay. Right, so it's built in correctly. Before we do anything, I want to so LVM objdump on our UEFI thingy that we've just built, and just take a look at what instructions it generated. And it looks like it's doing all the initialization sequence here. And then here it should, yeah, there we go. We have rep out B, out SB, which is our string print. It looks pretty okay to me. So let's run this and see what we have. Right, so here in QEMU, we just need to add this serial std.io that basically directs the serial output of our virtual machine to the standard input so that we can see it. And if we run our VM, and here we can see that we are actually printing hello serial. So that's pretty good. But I think we can do one better. Instead of just having a writer and having this write thing here. What I want to do is I want to have an actual proper login sort of interface that would take this writer here and then output to serial as a second step. But I wanted to format nice messages with login levels, info, debug, errors, and stuff like that. So that's what I want to do right now. So I'm going to add a new thing here, new file called log.zig. Actually, I'm going to rename this to logger.zig. Sounds better. And of course, we're going to need stud here. So let's import stud. And let's create. So here we need a public function. We are going to create a generic logger. So generics in Zig are basically types that are generated by functions. So let's call this function logger. And the I have some doubts about this, but in Zig, I think types and functions that generate types are all in Pascal case. So, and other functions that don't generate types are in camel case. So I'm a bit fuzzy on the details there, but that's how it seems to me at least. So here we want to take the writer type. So writer type, and this would be a type. And here we are going to generate a type from our function, right? Right, so let's return a struct. And in this struct, we are going to put our login logic. Let's start very simple. Let's create a public function. We'll call it debug, for example, dbg. And we want this function to take a comp time format, which would be just a U8 const slice, U8. And we want to take arguments, and these are an undefined type. So we'll in Zig, undefined types are any type. And this would basically return nothing, so void. Now, what we want to do here is we want to create a format. Let's start with something simple. So call this format, and this would be just a, let's just do something like this, and we attach that to format, for example. And then here we want to, so to do write to writer, right? So we need to define a writer on this struct here. So let's define a writer, which would be, of course, of type writer type. And this writer here, we can just set to something. So we need a value for this, right? And I'm guessing since this is going to be called on an instance of this logger, we are going to need to have a self, which would be a pointer to self. Maybe even a pointer to const self, since we don't really modify self, and we need, of course, to define self. So let's const. Let's create this here. Const self is at this. There we go. So here we can just immediately do something like writer dot print, and print takes a format and arguments, and of course we need to pass it our own format. Now the question is, Actually, I don't think we need to do this though. We can just let Zig decide how to pass it. Yeah, there's no harm doing that. So now we need to create a function inside of this that basically takes the. So here we are taking a writer type, and we are creating a generic type. So this structure is the generic type, but we need a way to create an instance of that generic type, right? So let's create this function called init here, and this function here will take a writer of type writer type. Come on, and it will return well, an instance of this current struct that we are writing. So it's self, and what it does is it returns, well, basically this struct, but it sets writer to be writer. There we go. So that looks pretty okay, and I think we can now go ahead and try to use this. So let's get rid of this, and let's create let's import. So const logger is import logger.sig. There we go. And here we can create let's call it log, and this would be logger.logger. We need to pass it a type which would be serial.serialWriter.writer. There we go. And we need to call init and pass it serial writer. Right. So I guess it's going to complain that it's not used, of course, and we are going to use it. So let's print a sort of debug message. And of course, let's put in some arguments, and this would be a, for example. Let's define const a to be u32, and let's set its value to 1 to 3. All right, let's build this and see what we get. Right, so we have an error here that's ignored, and I think we are going to need to return this error here. Otherwise, we are going to have problems. So if we want to return this error, we are going to need to define the error type here. And if we want to do that, then we need to get the error type as a so writer error should be a type, and this would be writer error. And I think with this it should be okay. We just need to go now here and do so serial writer serial error. There we go. And let's rebuild this and see what we get. Right, so we need to do something with this error that we are getting. So let's just swallow the error again and trouble. And of course we, does it do, I think it returns void or error, yeah, so it's fine. Let's build it now. Hopefully, okay, looks pretty good. So let's run it and see. Okay, so now we have our debug message printed with our argument. So now I think we can just go ahead and create the other methods. So let's take this and paste it, and I'll just do so debug would be inf. There we go. It's pretty cool. So this is using tpop's subvert, I guess it's called, the plugin. It basically substitutes, but it keeps the case. Right, let's do that a couple of times more. And I want inf to become warn this, and I want inf to become error. Right, so let's try this log.inf. And of course we need to not forget this, and it's something I do very often. Let's yank this and paste it here and do warn and error. There we go. Okay, so let's build this. The union is ignored. Error union is ignored, of course. So let's add catch unreachable to all of those. Yep, so this would go here, and let's run this and see what we have. Very, very good. So we now have enough to work with to debug our work without having to actually run a debugger or print stuff to screen and scroll the screen back and forth and worry about not having enough screen real estate to have all our debug messages show. So this will make our lives a lot easier. Well, that's it for today. We have our login infrastructure in place, and now we can start working on interesting stuff without worrying about how to debug it. It was a nice exercise to actually be hands-on with the language niceties of Zig. I know that I have learned quite a bit from doing this. As always, if you like this kind of content, please support the channel by leaving a like and a comment. And if you have questions or remarks, you can leave them down below, or you can add me on Twitter. Until next time, see ya. Bye.